Uh, Greetings. Welcome back to the continuing lecture in business math. This is Dr. Jeff Hong, and we are continuing with the depreciation method today. Of course, depreciation methods, and we are continuing with on with the straight line depreciation methods. And we'll be getting into accelerated depreciation methods shortly, but we still have to finish off with the depreciation in straight line depreciation in with the service life designated in output level or output quantity. Now, so we took a look at the in the last class. The last thing we did in the last session was the partial year depreciation, and if you remember, right, the partial year adjustment was made in the first year and in the last year, so that you would exactly end up with the salvage value at the end of the last year, right? So to do that, I basically this may be an additional step, but by doing it this way, you can you can make it more methodical, right? You can make it more methodical. You can make the adjustment more methodical. Yeah. So I'm not going to go back to that again because we got tons of things to do for today. So let's take a look at this example, today's example. So today's example was okay, let's take a look at this one. So this is today's example. Now, you might find, okay, what you might find, what is different? From the previous models, what is the salient or most conspicuous difference in this model? Well, you would see that in this model, life, look at the life. The service life, it cannot be years because, it's like what? 350,000 clearly is not in years, right? It is in quantity. In other words, output level, which means this looks like some kind of production equipment. So a production equipment, the service life of the production equipment can also be expressed in terms of the production units. And as I explained in the last class, just because the machine is 5 years old, it doesn't mean it is completely depreciated, because if you haven't used it at all, or if you have rarely used it, the machine would be in a perfect working condition, right? So you cannot do it that way. Also, you may be quite familiar with the wordings of the automobile, the car commercials. In the car commercials, they say, oh, um, Hyundai has a excellent, warranty warranty system. It's either uh, 10 years or 100,000 miles. So what does that mean? Why do they say 10 years or 100,000 miles? Because, even if your car is, 10 years old, if you haven't used it at all, it would still be in mint condition. It may have, like, even if it is 10 years old, it may have only about, it may have less than 5,000 miles uh, on it, on the odometer, right? So then the car is still in mint condition, right? Um, so they will um, honor, they will give you the warranty. They will honor it until it is 100,000 miles. So even if it is 20 years old, if it hasn't reached 100,000 miles, right, you get the warranty. Now, warranty service, right? So in this example, this machine, right, its service life is 350,000 units. Whatever this machine is, it is $75,000 when purchased. Now, here, let me first get rid of this because it was already filled in. And they should be, yeah. And here's something I want to also rearrange because this doesn't look, and I'm gonna do housekeeping thing later. But now, salvage value, that's kind of high for salvage value because when it is fully depreciated, it should have no value left other than the scrap metal value or zero, right? 5,000 is a very decent, very high salvage value. So let me turn it into like $150 for scrap metal value, right? Now, so then what is, okay, let me get rid of, so what is the depreciation rate? Depreciation rate is always 1 over life, whether it is in years or in quantity, it's still the same thing. So it's like, 0.0029%. In terms of dollar amount, right? Depreciation base, which is, cost minus salvage value, right? And then times depreciation rate. And you get what? 21 cents. 21 cents per uh, per unit. That means 21 cents per unit, right? So I would change the name to not annual depreciation, but it's annual. Yeah, it's true. It's of course annual because more generic, name would be depreciation expense. That means, of course, annual depreciation expense. Okay, and then so it depends on the output level. I mean, 4 years. Listen, 4 years doesn't necessarily mean just because it has run 4 years. It doesn't mean this capital equipment has fully depreciated. We would know if the sum of all these numbers add to this number, right? Sum of all this is equal to the service life that is fully depreciated. Let's see if it is, it could be just annually, it could be random, right? It could be, annually the output level could be random, but, let's see if it is, if it adds up to a, and yeah, this is just artificial example, so it is bound to add up to. It was designed to add up, but look at the production trend, and the production trend is nicely decaying, right? Or very naturally decaying. Why? Well, and it perfectly makes sense, logical sense. Why? Remember, when the asset is new, anything, any machine, any equipment, anything when new, it is at its highest productivity. It is at its maximum productivity, right? Remember the air conditioner example I used, right? When you buy a new air conditioner, um, what do you notice? Actually, you notice nothing, no noise, no nothing. But what you can notice is um, it's very quiet, and the room, it's very efficient, right? In other words, the minute you turn it on, uh, it won't take even a couple of minutes. The room gets cool, right? It cools down the room very quickly, and it works silently, and energy, most of all, energy efficient, right? You get, when you get your utility bill, right? You would notice that the electricity usage of electricity is very low, and that's the natural, that's quite obvious characteristics of a new machine, the new equipment, right? Uh, Efficient and high energy efficiency and high productivity. But as time goes on, it gets, it starts to make more noise, and it's becoming less energy efficient, right? And uh, the room doesn't, even after 10, 30 minutes, the room doesn't get cold, it rather gets warm. So warmer than the why? Because of the heat it generates. And normally it's supposed to be the 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 heat generated by the air conditioner should be sucked out of the to the exterior. But that's uh, when the machine is very old. That doesn't even work well. So isn't this very natural and reasonable decaying pattern that you would see, right? Okay. Anyway, it's not a difficult thing. Depreciation expense each year is simply the output of that year, right, times the depreciation uh, amount per unit. Okay. And uh, one more thing. Since I'm going to, it's going to be this times the output times this, right? So you don't want that F56 to change. So what do? You lock it. You got to lock it, right? You got to lock it, and you can now drag it down. Okay. I can probably, call it per unit. And then cumulative depreciation will be, in the first year, it's just itself. From the second year, it's going to be that annual depreciation plus the previous year, right? And then you drag it down, right? And the book value is what? Always the purchase cost, right? Minus the accumulated depreciation. Since the purchase cost will be repeated over and over, we're going to lock it by hitting F4. And we drag it down. And voila, what do you see? In the last year, the book value at the end of the last year should be exactly equal to, right, the salvage value, right? So it checks out, exactly checks out. Now, in our example, this was so artificially designed, right, so that it will neatly add up to each annual production level each year, right, was so artificially constructed, so it would nicely decline and then add up to exactly 350,000 units. But if it was so, it looks like as if 4 years is the its service life. No, it doesn't have. What if our output level wasn't like this? And our output was, suppose, let's say we're going to have, actually to reach, the maximum production level of 350,000. I mean, even in the first year, supposing if you have reached this maximum output level in the first year, then it is depreciated in the first year. But what if it is, the demand was so little, it took so many years to completely reach this point. Then suppose it was not, let's do this. Let's assume suppose it took 80 years. So then what should be the output? How do we know what? I mean, that means the output decayed or declined over 8 years, and still the sum would be 350,000. So how? Of course, how would the output look like? How should the output look like? Of course, if we use actual data, right? If we have actual company model, and if we have actual data, right? We would have to follow that. But since we are working on a hypothetical example, right? What should it look like? I mean, to make 350,000 spread over 8 years in declining pattern. This is an interesting question. I mean, how would you spread the production level over 8 years, right? In a nicely declining pattern. When I say nicely, I don't know any better word, but like systematically declining, neatly systematically declining pattern, right? And still add up to 350K, right? Is there a methodical way to make it decline in a systematically declining pattern? Yes, there is. So then think about it. What do we? So how should I do that? We can do it this way. First, I'm going to sum all of these digits, right? If you sum all of those digits, right, using auto sum, right? Where's the, there you are, 1 through 8, and it's going to be 36. I can also easily do it mentally. I mean, if you add 1, 1 and 8, if you add 1 and 8, that's 9. 2 and 7, that's also 9. How many pairs are there? There are like 4 pairs of 9. Okay, 1 and 8, 2 and 7, 3 and 6, 4 and 5. They all make 9, and 4 pairs of that, 4 times 9, right? So, okay, and then what? Let me do this first. Oh no, what did I do? What did I do? Bottom. Okay. Then, if the sum of all these numbers is 36, and if I use, right, 8 and divide it by 36, I'm going to log that. Okay, in descending order, right? If it was, let me do this, and I'll do this, and then just see what I'm doing. In reverse order, right? Oops, what happened? Oh. And then this is actually weight. So let me insert, let me insert a column there. And then actually this is the weight. And then again, 5, 4, 3, 2, and 1. So what do you see here? Now you are looking at the fractions, right? The fractions of, in reverse order, right? So this is 8 over 3, right? 8 over 3. And this is 7 over 30, 8 over 36, 7 over 36, 6 over 36, right? In that, descending order, right? And then these weights, these fractions are basically the distribution of weight, right? You are, in other words, you are distributing, if you want to allocate the most weight, and the most weight out of this is 8 over 36, isn't that right? Second most weight will be 7 over 36. Third most weight will be 6 over 36. And then they will all, these weights will are basically, designed, constructed to add to 1, right? Because it's so, allocation of 1, right? Distribution of 1, right? So for those weights, I'm going to use, only like 3 decimal places. That's too much, right? Let me call that, weight. Okay. So then what do? That's exactly like the depreciation rate per year, right? So in the first year, 22% of this 35,000 was produced, right? So you just simply uh, uh, multiply that by this, okay? And I will lock this. I will lock uh, D56 so I can copy and paste it. And of course, we are dealing with physical units. Whatever, since we are dealing with physical units, um, the output would be rounded to the whole number. So I'm going to decrease decimals, right? It should be rounded to the whole number or integer, right? And then I will simply drag it down. There you go. Now the depreciation expense is then, and it's basically not that one, but this one, right? Okay, and then you drag it down. Okay, I'm gonna move the sales value down there, and then drag it down. See, we ended up with the salvage value of 150. So the whole thing worked out. It checks out, right? Makes sense. Now this technique, right? This technique has a nice name. This technique of what technique? The technique of distributing the weight or allocating the weight in a nicely declining pattern, right? It's got a name. It's called Rule of 76. Rule of 76. Why is it called Rule of 76? Or 78, I believe. Rule of 78. Why? Where does the that 78 come from? Where does that come from? Now, if you think about it, you remember. Oops, you remember what I did to find this sum, right? Some of these numbers, I added, I made pairs of, the first number and the last number, right? Second and the second from the last, I made pairs, and there were like 4 pairs of 9. Now, in the old days, before even in like ancient Greece and Egypt, ancient Egypt, Greece, people were not that stupid. Of course, they were not stupid. What I'm saying is, uh, they may not have had the technology that we have today, but their intellect was no less than what our intellect of modern day Homo sapiens. So even in those days, although they didn't have a computer, uh, they devised a very brilliant and clever ways to uh, calculate the interest on a loan. For example, you learned in the time value of money, Remember the amortization? In amortization, basically, all monthly payments, you make, a regular amount, payment of regular amount, right? Constant amount at regular interval, right? And the monthly payments break down into interest and principal, right? Remember? But the amount, the proportion of interest and principal repayment within that, monthly payment is not constant. They are not by constant proportion, but the proportion changes over time. And remember, the interest early on, you pay the most interest, and the interest gets smaller and smaller and smaller as time goes on. And early on, in the first month, you pay the largest interest, but the smallest principal. And as time goes on, the principal gets bigger and bigger and bigger. Principal payment, right? Gets bigger, and out of that, monthly payment, right? The portion of the principal gets bigger and bigger and bigger. So interest, the benefit of that kind of structure in the monthly payment is that the lender will maximize on the interest early on. So what implication does it have? What is the benefit? I mean, to get the interest, most of the interest early on. Look at it this way. So, and I also explained it when we did the amortization schedule. Suppose you bought a car with financing, so you're making monthly payment, and it's like 5-year monthly, so 60 months, right? 5 years, 60 months. So you're making 60 monthly payments, and for the first 2 years, I mean, for 24 months, you were making, good payments. You made payments on time, and everything was going well. But suddenly, at some point, like on 25th month, you lost your job, and you cannot make the payment. So what's going to happen? The bank, the lender, will repossess the car, right? And then when they repossess the car, that means they're not going to make the interest anymore. But look, most of the interest has been paid already in the first 24 months. I mean, the lender won't get the interest for the remaining 3 years, but most likely in the first 2 years, there was more interest, right, than the remaining 3 years. Okay, makes sense? So they already, maxed out, they got the maximum interest, they can. And then when they repossess the car, they recover the principal, because if they sell it off, they sell it again, then they basically recover the principal at its current market value, right? Another thing, and then you might wonder, so they still forgo or miss out on the end for the remaining 3 years. They don't have to worry about it. It's their job to worry about it. But they won't lose anything, because think about it. When they sell that car, there will be new financing, right? So the new buyer will start paying the interest from month one, from the first month, right? Although this is a used car, but still, on the remaining balance of the value on the car, right? The car is 24 months old, so from at that point, it will sell at the value of a 24-year-old car, and as long as it sells for or above the remaining principal value, right? Then the lender is losing nothing. They sold a car at its book value, right, or above, and then they lend the money to the new buyer to finance it. So the payment starts from uh, the month one for the new buyer, and the first every monthly payment includes again interest, right, on the principal loaned out, right? So the lender loses nothing that way, right? So it's really a win-win game for the lender, right? Um, of course, it's not a losing game for the borrower either, because anyway, the borrower used the car, right, for the first 2 years, the first 24 months, making the monthly payments. So uh, obviously, it's either renting the car. It's like, you have rented a car for 24 months with monthly. Of course, you made a down payment. That down payment is gone. But as much as the down payment is deducted from the loan, uh, so it's basically, it paid out well for both parties. But why am I talking about that? The amortization schedule was done on Excel, and we were able to do that because thanks to the modern technology. I mean, without the computer, you might think, oh, how can I do that? Of course, without the computer, it's going to be very difficult. It's going to be uh, not. It may not be impossible, but it's going to be a really pain in the neck to manually calculate that. But they did it. They did that kind of amortization. They built that kind of amortization schedule, even in the ancient Greek or ancient Egypt. How? You might you get you might be surprised. How? I mean, they didn't have any computer at the time. No, they didn't have any computer at the time, but they were still able to break it down in a declining pattern like that. How? They could do it like this at least, right? Why? So, why is it called Rule of 78? Now, let's think about it. Why is it called 78? Rule of 78. So you break it down, you break the interest uh, over, uh, uh, let's say, a year, and the payment is made monthly. And there are 12 payments per year. So 12. And how many pairs? I mean, if you uh, you just lay down the numbers like this, 1 through 12, and make pairs. Like front end and the tail end, you make pairs, right? How many pairs are there? There will be 6 pairs. Isn't that right? There will be 6 pairs of 13. 1 and 12, 2 and 11, right? 3 and 10. There will be 6 pairs of 13. So 6 times 13, what's that? 78, right? Then you, with a 78 as the sum, you do this. And the highest weight will be the highest weight will be used in the first month. So that's going to be 12 over 78, and then 11 over 78, and so on. In the last month, it's going to be 1 over 78. And it's going to break down the interest exactly in that declining pattern, right? Exactly in that declining pattern. And you will end up nicely, uh, uh, you know, breaking up the monthly payment into interest and principal in that uh, nicely declining pattern. I mean, declining for the interest, but uh, increasing for the principal, right? You get that? So how clever it is. That was very clever, right? Considering that it was like, more than 2,000 years ago, 3,000, 4,000 years ago, and people were still able to figure it out. And when, come to think about it, they were smarter than most of the people these days, right? That's very clever and brilliant, right? How many of you have even thought about it? Hmm? Yeah. Of course, this even in those days, like ancient Greece or uh, ancient Egypt, not everybody was able to do that. It's just people who were just smart, right? That could do that. And of course, even if you're smart, you have to learn it. I mean, you have to learn it from someone or from somewhere. Maybe geniuses can come up with an original idea, original method, right? Or, but that's genius. But other than the geniuses, right? At least um, even smart people will have to learn from someone somewhere. But it's the people who don't even try to learn, people who don't even after, even if they learn it, but still, don't get it, or, just forget immediately after, the exam. Well, then there's no answer for those people. But there's no secret to that other than practice, practice, practice. Repeat and practice, repeat and practice. That's the only way to make it, right? As the saying goes, practice makes perfect. So remember rule of 78, right? Remember that? It's called rule of 78. Okay. Now, so this brings us to the conclusion of straight line depreciation. And now we're moving on to the accelerated depreciation. Okay, accelerated depreciation. Now, remember, now this is the time to answer my question. What was the question? I gave you this question for food for thought. Remember, the companies, if possible, if they were given the power to choose, right, between the writing off the expenses in year one or depreciating it over many years, they always would choose to write it off in year one. And my question was, why would they want to do that? I mean, isn't it the same thing if you write off $50,000 for the car in year one, or just spread it over 5 years? Still, it's 50,000. You write off 50,000 just over 5 years, and write off 50,000 in 1 year. I mean, still, isn't that the same thing? Still, it's 50,000, right? But it is not, right? The answer was they are not the same, 50,000. Why? My question was why, and I gave that to you as food for thought. Did anybody come up with the answer? Why the companies prefer to, the former, right? Not the latter, but the former. Um, if anybody came up with the answer is is the present value, right? And I've been telling you, if you have taken this class, you would uh, be able to think like a finance professional. You should be able to think like a someone who learned uh, time value of money. There's time value of money, isn't it right? If you get the tax deduction of $50,000 today, or tax deduction of $50,000 over the next spread over the next 5 years, which one is better? Well, getting the tax deduction now, today, $50,000 tax deduction today is better. Why? I mean, isn't it still, 50,000 tax deduction over 5 years? No, it's because tax deduction, $50,000, present value of the tax deduction, $50,000 tax deduction today is greater than the present value of $50,000 tax deduction spread over the next 5 years. What difference would there be? It's the difference in the present value. Make sense? Okay. Now, if you understand that, now you understand the reasoning, the rationale behind the accelerated depreciation methods. Why? Because they want to depreciate as much as possible early on because of bigger present value of the tax deduction, right? But then they don't allow, right? IRS doesn't allow writing off the expense in year one. So instead, what do they do? What do they allow? IRS allows accelerated depreciation. In other words, you will depreciate over 5 years, but you will allocate more weight in early years, so you get more more tax deduction in early years, and less and less in a nicely declining pattern. Okay, doesn't that ring a bell? Now let's take a look at this example. There are two accelerated depreciation methods. One is sum of the year's digits method, and the other one is uh, um, declining balance method. Declining balance, right? First, sum of the year's digits depreciation method. Let's take a look at it. So 5 years, you have, so this is the company car, right? You've paid $50,000 for that, and you depreciate it over the next 5 years. And then if it is a straight line depreciation, every year it's the same, 20%, 20%. But look, in early on, you have 33%, 27%, 20%. Nicely, the depreciation rate, the rate is in nicely declining pattern. And the sum of all those weights is 100%. But doesn't this look familiar? Huh? Where did you see that? You just saw that a while ago in the in this life in, right, service life defined in production level. And what was it called? Rule of 78. So is rule of 78? This is exactly rule of 78, just called by a different name. Think about it, sum of the year's digits means what? If you sum, it's 15. And then, right? And then, I just, sorted it in reverse order, right? So that it would be nicely, if you just, do this, right? Just locking in B10, and by dividing, this cell by B10, and you just drag it down, right? You get nicely, declining. You get the weight in a nicely declining pattern, right? So this is called, some of the years digits, but another name, rule of 78. And we can, and we can do it wonderfully. It's not a difficult thing. So let me do some. Okay, and also this is what they did in the old days. And without the computer, you cannot. There's no auto sum. Then what do? Uh, since there's no auto sum, the best thing you can do is, I mean, if it is like 1 through 12, you can easily see how many pairs of the first data point and the last data point. Some of how many pairs of them you can make, you can easily see. But if you have a long string, like 60 months, right? It's not that difficult. You have 61. How many pairs of 61 do you have? 30, because um, but in the old days, this is what they did, right? Uh, n times n plus 1 divided by 2, right? But anyway, we can do it easily by Excel, by using, a sum command, right? Sum, right? Or auto sum, right? C5 to C9, right? We can do it like that, right? Or if you prefer, you can do also like that. Okay. Now, let's take a look at the next example then. So this is not a complete example. Let me do this. Everything is digits just right. And what else is missing? You know what's missing? Accumulated depreciation and book value, right? Actually, the book value should, this should come here. So, I'll do that. So suppose you have an $18,000 asset. That's the book value at time zero, which is the purchase cost. Salvage value is kind of high. Let me make it 300, right? And then the depreciation expense would be, oh, this is the, yeah. See, this is the depreciation base and time the rate, and it's nicely, it's nicely done like that. And then, so the depreciation expense, it's not depreciation expense, I'm sorry. This is the cumulative depreciation. Cumulative depreciation to make it complete, right? And this is value, right? And the cumulative depreciation in year one is just itself. Year two And then the book value is purchase cost and lock it minus a cumulative depreciation. There you go. And you drag it down. There you go. See? And then I don't need it here because anyway, that's the salvage value, right? So the book value at the end, right, is the salvage value, right? Exactly the salvage value. So our depreciation schedule is complete and it checks out. It's perfect, right? All right. So so this is the sum of the digits method, or as the first technique of accelerated depreciation, because you can see, as you can see, uh, early on you depreciate the most. It's not a straight line, right? It's rather, if you look at the book value will be declining fast, right? Rather than a straight line. So next is now in every, as I said before, in every depreciation, in every case of depreciation, partial year is partial year is a recurring thing, a recurring problem. Why? Because there's no guarantee. I mean, it's not necessarily that you buy the asset on January 1st, right? In any year, right? You can purchase the asset at any random point during a year. So it could be, June 15th or, May 13th, May 21st, March, 17th. I mean, the day you purchase that asset, and that asset is the day you have installed that equipment or capital asset in your company, right? That's the starting point. So we cannot use a simplified assumption that assets are always, starting from the first day of the year, right? So a lot of assets are not, in a lot of cases, the assets are not owned for the whole year, right, in the first year. But it was not that difficult. It was rather easy to make adjustment in the straight line depreciation because the adjustment was made. I mean, you only needed to make the adjustment in the first year and in the last year. But it's not the case with the accelerated depreciation. Why? Because think about it. If you make the adjustment only in the first year and last year, then it defeats the purpose. It completely defeats the purpose of accelerated depreciation, right? Now think about it. Why? Because making an adjustment in the first year, yeah, you have to do that. But then you remember in the first year, the most weight is applied in the first year. But if you own that asset only for half the year in the first year, that precious, the biggest weight, that precious biggest, largest weight, right? The highest weight is wasted. In other words, you could use only half. You can use that weight for only the half year, right? So the trick is then you will need to extend this maximum weight as much as you can. So in other words, you will need to stagger it. So we're almost out of time, so we cannot do the example of the partial year depreciation today. But as just to give you an idea, uh, to make this adjustment, it's more of a uh, like tedious, more. Uh, uh, it involves more, uh, you know, case by case or line by line adjustment, year by year adjustment, which is a rather a tedious job. But it's just you just have to set it up for like first 2 years, and then you can just drag it down, and right. So again, doing this with Excel, of course, Excel makes life a lot easier. So anyway, then we're gonna be we're gonna continue with the partial year adjustment in the next class. Okay, so we're gonna have to call it a day here because the time's up. We don't have any more time to discuss it for today. So thank you for watching, and I'll see you guys in the next class. End of video.